we are ready to prove some trig identities. So we're going to be using the basic identities, the fundamental identities that we went over at the beginning of this section, the algebra skills that we just reviewed to sort of manipulate some expressions to try and prove some more complicated identities. And I've got two really important rules for proving identities up here on the board. Proving something is writing a systematic, step-by-step logical argument to demonstrate that something is true. Okay? It's all about the work. You're going to be given a statement that's true. You're explaining why it's true. Okay? First rule is you can only work with one side at a time. So in general, if you have an equation, it's going to have a left-hand side, which I'll usually abbreviate LHS, and it's going to have a right-hand side, which I'll abbreviate RHS. Okay? You're trying to prove that the left-hand side equals the right-hand side. In doing that, you don't get to assume that they're the same. So you have to pick a side and only work with one side at a time. Let me show you why. Okay. Let's suppose I was asked to prove that 2 equals negative 2. Well, I can't prove that because that is false, right? Okay. But if I have two things that are equal, whenever I do have an equation that's true, I know that I'm allowed to change both sides of the equation. As long as I do the same thing to both sides, it's okay. So what if I squared both sides here? I get 4 equals 4. Now that is true. Okay? I started with something that's not true. I changed both sides. I ended with something that is true. Now is that a proof that 2 equals negative 2? Absolutely not, because I started with a falsehood. Okay? But that idea that you can do the same thing to both sides supposes that both sides are equal. And if that's what you're trying to prove, you're not allowed to just assume that they're the same. You've got to simplify each side separately. Now, I have this parenthetical expression here that a table is not okay. I want you to be writing up a formal mathematical proof. So if you're working with one side at a time, there are sort of two ways that you can do that. One is you can just pick the more complicated side, start with that and simplify. And if you can simplify it all the way until you arrive at the other side, fantastic, you're done. Okay. The other is what I call the 3-paragraph method, where you can start with the left-hand side and you can say it's equal to this, which is equal to this, which is equal to this, and you can simplify it as far as you can get, and then say, I don't know where to go from here, so I'm going to stop. And then you switch, new paragraph. You're going to work with the right-hand side, and you're going to say that's this, and that's this. Oh, and you get to the same thing. That's your second paragraph. Third paragraph would be to say the left-hand side that is equal to the right-hand side, just to point out, hey, I got them both to be the same thing. If you're going to do that, and that's a perfectly legitimate way of doing things, a table like this doesn't count. Where you say, I'm going to simplify the left-hand side here, and I'm going to simplify the right-hand side here. Unfortunately, when I see people do this, they very often simplify the left side, simplify the right side, and then just throw in an equal sign in the middle. And it really obscures the fact that this work was just with the left side. That work was just with the right side. And then I took a step back and I said, they simplified to the same thing, thus they are the same. Okay. So I don't want to see, even though some of you might have done things like this before, I don't want to see just a table where you're simplifying each thing. Okay. All right. And then the second rule is that the statement of the problem is not actually part of your work. Okay. We're about to do problem number 38 from your text. Okay. By the magic of video editing, question 38 has appeared on the board. What happened is I had miscopied the problem initially, and I went to prove it, and I was like, oh, that's not true, because I hadn't copied it right. So here we have this. Okay, now that's the statement of the problem. That equal sign has not yet been justified. My entire task is to try to prove that that equal sign is true, that that side does equal that side. When I'm writing a proof, my whole job is to justify every equal sign that I write, to take baby steps so that I can explain each step of the way why this thing is the same as that thing is the same as that thing. Okay? So what I will do is I will label, that's the left-hand side, and that's the right-hand side. And I usually pick the more complicated side, which in this case is the left-hand side, because I would rather take something complicated and try to make it simpler than take something simple and try to make it more complicated. Okay. So I'm going to say the left-hand side is sine of negative x plus cotangent of negative x times cosine of negative x. Yes, I am recopying exactly what that left-hand side is. I can't use this copy and save myself the time it takes to write it out because this copy is unjustifiably connected to the right-hand side. I need to be able to justify any equal signs that are part of my proof. Okay, so I recopy that side exactly, and then I can see in each one of these we're plugging in the opposite of x. That makes me think we want to be using our even-odd identities. Okay, so sine is an odd function, so I know that that's negative sine of x. Plus, I guess I don't need those parentheses. Plus, let's see, cotangent is odd. Remember, the only two that were even were cosine and its reciprocal secant. So this is going to be the opposite of cotangent of x. Cosine was even, so that's times cosine of x. Now, if I hadn't remembered that cotangent was odd, I could have rewritten that as cosine over sine, and then I would have gotten the same thing. Okay, so now let's see. When in doubt, I'm going to rewrite everything in terms of sine and cosine. Here, I didn't start with that because I could sort of see an opposite input. I wanted to use even odd. But almost always, if I don't see something super obvious, I'm just going to rewrite things in terms of sine and cosine. Okay, that's my go-to strategy. So we've got negative sine x, and then let's say I can say this is going to be minus. Cotangent would be cosine of x over sine of x, and that's times cosine of x, which I can just write as over 1. Okay, so we've got negative sine x minus cosine squared x over sine x. Okay. Looks like what we're going to want to do is combine these to just get one term. I want to do that because I know this is my goal. I'm trying to get to this thing, which is just one piece. Right now I've got two pieces. So let's try and get ourselves a common denominator. So I could write this as over 1. Okay. And then to get a common denominator, I would basically just multiply that by 1 in the form of, oops, that marker doesn't work. 1 in the form of sine x over sine x. So what I have here is equal to 1 copy of negative sine x over 1 minus cosine squared x over sine x. So if I multiply that out, that's negative sine squared x over sine x minus cosine squared x over sine x. Since the denominators are now the same, I can write that as 1 fraction over sine x. And on top, I've got negative sine x minus cosine x. Negative sine squared x minus cosine squared x. I dropped those squares for a minute. Ah, that was careless. Okay, both of these terms are negative. If I want to, I can factor out that negative. So it's negative 1 times sine squared x plus cosine squared x over sine x. But now, there's my Pythagorean identity. I know that that's the same right there as 1. So all of this is just the same as negative 1 over sine x. Oh my goodness, that's negative cosecant of x, which is my right-hand side. Okay. So here's an example where I was able to start with the left-hand side, and I just took little steps to either just do some basic algebra or to use my fundamental identities until I arrived at the right-hand side. Okay, kind of nice. Now, I didn't start this out saying, I'm going to arrive at the right-hand side. If I got stuck, I would have switched to the 3-paragraph method. I would have said, I've simplified the left-hand side as far as I can. Now, let me try and simplify the right-hand side. And I'll make sure that in the next example we do it that way so that you can see what the other option is.